earlier. I mean, not a video, an email describing that there'll be a quick lecture today that's just going to cover your test. So here, just go to any particular one. There's not going to be a word of the day today. Okay, right here where it says exam website. Okay, it exists in every single course in dynamics, in fluids. There it is, exam website, and in statics. Okay, for some reason this one starts on the federal attendance module. I can fix that later. There it is again. If you click it, it's going to describe how you get in. I created a copy in the email. I don't want to necessarily put this on the video for that long. So let's go out there to this. Okay. One of the things atu.5thn.com. I, of course, already have an email. I mean, a account. You have one as well. When you first come up, it looks kind of like that. It's kind of boring. There are 3 classes. You don't have access to anything till you log in. Now I'm going to go through each of the classes here. I've already did a little bit in statics. One of the things is every single class has this CP001 in the test. That's a common problem 01. I allow 10 attempts at it. You get 5 hours to do it. It probably should take you around 10 minutes at most. I have had 2 attempts at it. I can continue my attempt, but one of the things you're going to see, well, here we go. So here's my attempt. It's basically a triangle, and you have opposing sides. If you go out and use the law of sines or the law of cosines, you should be able to find all of these. This is one of the advantages of, and why I particularly do use this server that I've got out there and pay for myself, is that if you notice you have a picture. Of course, you can do a picture like that in Blackboard. You can list out a set of numbers, but generally speaking, you do not have the ability to do what's called a clause statement. Of course, I may be mispronouncing that, but in other words, I can do or ask multiple questions about the same problem. So it's possible to get partial credit. So if the sum of all angles in a triangle submit it all and finish it and give it a second. I got 25% or 2.5. All the problems are going to be out of 10 points. They'll be scaled and put back on the thing later. Okay, it took me a long time to do the problem because I started it yesterday. And so at the end of this particular one, he talks about, or I put this little tan sheet in here in which I linked this Khan Academy video about sines and cosines. What you'll notice is, yes, I got one of them correct. But if you hover over each of these, it'll tell you the correct answer. But now, what happens is, just remember 50, 19, and 35. 50, 19, and 35. Now, it's 43, 22, and 20. So the numbers change each time you go through the problem. So now this remains the same. It'll be 180. So you solve it. You get, okay, right now it's telling me I still have some time left. I'm going to submit all and finished. Okay, so I still got my 180, but what you notice is, like you say, you hover over each of these, you get the answer for this set of problems, this set of numbers. So I would say play around with the common problem first for a while. Um, we will go to the last problem in all three classes. Here's MT07, or MT007. I apparently was, oh, that's right, I launched it the other day. So here's the problem. I made this instead of a rope, I called it a strut. It's a rod that goes from here at B to D to hold the bucket, because it could be based upon the dimensions A, B, C, D, E, and F. It could be the smaller lowercase, that is. It could be that this member right here might be in compression, and a rope can't take a compressive load. So what you find out is the weight of the bucket and all of the dimensions. And then, just like the reason I use this is you can have multiple responses for one problem statement. In this case, the problem statement is the picture combined with some of the words here and the weight of the bucket. So, and it's asking you for the load in this line, in this line, and in this line. So there are your things. Okay, so you have to remember tension in the blue strut, dB in pounds. Note, in this case, tension is positive and compression is negative. So I'm not even going to attempt anything there. So that tells you at this particular point in statics, we've covered enough material in the lectures that you can do this. This is the last problem there. So let's go back to dynamics. Hang on. Okay. So again, the common problem here is your common problem. Guess what? Same exact problem here. I just wanted to do that common. That's the reason it's called a common problem. It's common to all three classes. Let's go to the last, the MT005. I should have just called these a midterm instead of test one, but yeah. So if you look at this picture and you see there's one rope wiggling through all the way from this connection here all the way to the block A, we've covered enough. This is the last part of chapter 12. We've covered enough that this problem is doable. So let me go back to the one previous to it. Let's look at it to make sure that it stays within the confines of chapter 12, and it does. There's it. Now this is one case right here where pay close attention to this. Okay, well, first let me describe this. Okay, so here's your geometry up here, and this is a geometry that came directly out of the book. I've added a little bit, like the x and y coordinate, this red vector here. But in the creation of this problem, which there's the equation, there's some of the information. So you see the 5.7 here and the 5.7 here. 3.84. The D's, the R is a function of D, which I don't know that, no, it was not on the drawing. And you get down, and there's a couple of things. Note the polar coordinate. In polar coordinates, the velocity may be written as this. And for some reason, I have an asterisk there instead of a dot, but in polar coordinates, the acceleration may be written like that. The polar base vectors do not vary in length, but do vary in direction and are both a function of. For details, refer to, and if you click this, it'll launch a lecture notes from a course that was up in MIT, and this is not like super advanced. This is pretty much existing in all dynamics textbooks in one way or another, in which he describes how. Now, ours is UR and U theta. His is ER and E theta. He describes how you can come up with a mapping between ER and his, or UR and ours, and the I and the J. Now, this geometry that you see, this picture that's generated here, is the exact representation of the data here. So it's not a generic visualization like this is. It's an exact representation, and that's useful because this red thing is the pin, or this thing. Now I didn't draw this part or this. I just draw from here to here and the arc. So it's not perfect, but position wise this is okay. And like I said, here is a chance to get multiple or I'm not partial credit. So you have R theta, R dot, R double dot, theta, theta dot, theta double dot. These are the 6 things you need to know in order to start hammering out the rest of these. Everything is correct within 5%. So I can go back and monkey with something and show you that in a minute. If you answer all this, now this one is a unique one because, and I'll show you why. Once I finish the attempt, here I'm going to return to the attempt. I want us to memorize that geometry. I'm going to go back. But this time I'm going to submit it. Now this one, okay, here's the picture again. We're going to look at our next case and we're going to see how this picture changes. Of course, I got everything wrong. I can hover over everything and it'll tell me everything for this set of numbers, this set of constants which are up here. But if you roll on down, oh wait, oh no, that's the problem in the final that has the solution. Okay, so let's look at this. I'm going to reattempt it now, remembering the geometry. This time, you notice this picture is different. This looks like it's tilted almost 92.3 degrees. So guess what? This is 91 degrees. That is an exact representation. The angle from here to here to this is 91 degrees. So this is a generic drawing with constants and distances and things like that. This is specific to the exact numbers that you were given here. Okay, so let's head off into fluids. So again, everything is available. Here's the common problem again. While I'm doing this, I'm going to look at something, okay? It says everything's within 5% of the solutions. Well, we know this is 180 degrees. Okay, 10% of 180 is 18. So if I divide that by 2, 18, let's just say 185. Would that be correct? And guess what? It's correct. Why? Because it's within 5% of the solution. Now, if I go back and finish the review, reattempt, start an attempt, and this time I go down in 189. So finish attempt there, submit all, finish. Oh, so I think I needed 189 point something. Okay, let me do it again. Okay, 189.1. So now it's wrong. So okay, so 10% of 180 is 18, which half of that's 9. So 5% of 180 is 9. So when I put in 189, it was okay. It was within was within that 5% and less. When I did a 0.1, that moved it 9.1 or a little bit greater than 5%. So you have a little bit of buffer zone here. And for actually, let's see, for actually fluids, that is very, very important because there are many times that the viscosity and things like that are, let's just say, you'll need that 5%. Statics and dynamics, not so much. So here's your last problem in there. And I'm sorry for, in a bigger screen, or you can hold the control key button down and do like this, and the problem becomes, in other words, this picture doesn't fold over onto this gray area here. So here you have a concrete, and obviously I drew this by hand. Here's Lake Darnell, which I misspelled. Here's a hinge. Here's your gate. Here's a force F0. It's going to be used to push the gate open. And some of the facts. The gate is 1 foot into the page. The light blue gate has no weight, so this has no weight. It's like perfectly balanced, has no weight. The light blue gate has supports to rotate around the hinge, which is right there, that funny color there, to open and close. The light blue gate may be open with a load F0, which is right there. Here's your gamma, here's your H, here's your R. And there you go. There is 4 questions related to that. So at this point, all 3 classes, everything is available there. You've covered enough. We've covered enough in here to work these problems. So I would say head off to it. And there's a rendition. That's a hand-drawn thing. I went back and put this C in the gate here. You obviously tell that. 3 questions here. So everything is doable in all 3 classes at this point. So here's a manometer. So with that, I'm going to go ahead and cut this video off, and we'll go from here. And I am sorry I'm under the weather today. And obviously we're having, not only am I under the weather, we're all under the weather because it's about to snow in a minute. So I recorded that this morning at 7:47. If you look up here, I can see the time, but I can see the date, but I can't make that any bigger. By the way, this is a Linux operating system, so I tend to stay in that world.